Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to be learning about linear motion. This video lesson will be covering an introduction to distance and displacement, speed and velocity, as well as acceleration. Now, first things first, what does linear motion mean? From this term, it's quite obvious, but we'll go through the meaning anyway. So as you know, the term linear means straight line, whereas motion refers to movement. Therefore, linear motion specifically refers to movement in a straight line. So under the concept of linear motion, we will be learning about distance and displacement, speed and velocity, as well as acceleration. Now, the thing is about distance and displacement, as well as speed and velocity, you have to understand the concept of scalar and vector. If you have not learned about scalar and vector, please watch my video where I explain the concept of scalar and vector and what the differences are. For now, let's get into the comparisons of distance and displacement, as well as speed and velocity. So when it comes to linear motion, it's all about the objects moving in a straight line. It's possible for the object to change direction, but throughout a particular motion, the object will be moving in a straight line. And this will be seen in the examples in the next few slides. So here's a very simple example. We have this in 2D, and we're first going to look at distance versus displacement. So let's say we have a red ball that's going to be traveling from O to R to S. So if we were to calculate the distance, so when traveling from O to R, first it has traveled 10 meters. And then when traveling to S, it has gone backwards. But in this case, because we're calculating the distance traveled, you just need to count how far the object has moved overall. So that's why we add another 10 and 8 meters as per the diagram. This gives us the total distance traveled of 28 meters. So you can see that in this case, it doesn't matter which direction that the ball is moving. When calculating the total distance traveled, we just count what distance it's actually moved. Just like if you're in a car, you would observe the odometer and see how far you've actually moved. It doesn't matter which direction you're moving, it's just how far you've actually traveled. However, when we want to calculate displacement, let's start from O again. Now, displacement has both magnitude and direction. So in this case, we're going to express a direction by using positive and negative. So when the red ball is moving to R, it's moving to the right, so we take that value as positive 10 meters. Now when the ball moves to S, it's moving to the left, so we're going to take that displacement as negative, and that's why we have minus 10 and then minus 8. So this is how you calculate displacement. As you can see, when the object moves from O to R and back to O, the value kind of cancels itself out because it goes there and comes back and then moves backwards again an additional 8 meters. And that's why you end up with a displacement of negative 8 meters. So this proves mathematically how we get the value of the displacement. So now that you understand this, let's look at an easier way to calculate displacement. All you need to do is find out where it starts and where it ends and take the displacement from start to end based on the magnitude and direction. In this case, we can see it starts at O, ends up at S, so direct from start to finish, it's 8 meters to the left. And that's why a simple way of determining the displacement is just putting it as negative 8 meters based on the start, end, as well as the direction. Now, let's look at the speed and velocity. Say in this case, when traveling from O to R to S, the time taken in total is 20 seconds. Let's start first with the speed calculation. We already know that the distance traveled in total is 28 meters. So to calculate the speed, all you need to do is take the distance of 28 meters divided by 20 seconds, and that's how we get 1.4 meters per second as the average speed of the entire motion. When it comes to velocity, we need to take the value of the displacement. So we know the displacement is negative 8 meters. The total time taken is 20 seconds because that is the total time for the entire motion of this red ball. So that's why the velocity is negative 8 meters divided by 20 seconds, giving us negative 0.4 meters per second. That is the average velocity for the entire motion of the red ball traveling from O to R to S. Let's look at one more example. So again, we're going to have the same red ball with the same setup, but this time this red ball is traveling from O to R to S and back to O. Remember that when calculating distance, it doesn't matter which direction that the object is traveling in. So when traveling from O to R, the distance traveled is 10 meters. And then when it goes to S, we're going to add another 10 and 8, and then back to O is another 8 meters. This gives us a total distance of 36 meters. The displacement, on the other hand, would be positive 10 when it travels to R, negative 10 and another negative 8 when it moves backwards to S, and when it goes back to O, we add 8 meters again. So mathematically, when you look at this gives us a displacement value of 0. Now let's recall the faster way to determine the displacement. All you need to do is look at the start, the end, and the direction. In this case, you can see that the start and finish are at the same point, and that's why this red ball has 0 displacement. So in spite of all its motion, because it started and ended at the same point, the displacement is 0. So now let's look at speed and velocity. Starting first with speed, if let's say the time taken for the entire motion is 25 seconds, we know that the distance traveled is 36 meters. So we take the speed as 36 divided by 25, and this gives us the average speed of 1.44 meters per second for the entire motion. For velocity, we're going to take the value of displacement, but we know that the displacement is 0, so it doesn't matter what the total time is. If the displacement is 0, therefore, the velocity is also 0. It's as if the object never moved, even though it did. But that's a thing when it comes to vector quantities. For displacement, we look at the start and finish. And because velocity depends on the value of displacement, that's why we also look at start and finish. In this case, both values are 0. Let's look at one more example to help you cement your understanding of distance, displacement, speed, and velocity. In this case, this is not a flat line. We have a situation here where we've got different directions. So let's say someone is going to start walking from home to a shop that's 3 kilometers away. Then from the shop, the person takes a right angle turn and travels 4 kilometers to go to school. So if you want to calculate the distance, all you need to do is add the two values up together. And that's how we get the total distance traveled as 7 kilometers. Let's say this person took 1 hour to travel. So therefore, the average speed in total would be 7 kilometers divided by 1 hour, giving us the average speed value of 7 kilometers per hour. So in this case, how are we going to calculate the displacement? We can't use positive and negative because the directions here are different, right? So let's recall what we've learned earlier. To determine the displacement, all you need to do is find the starting point, the ending point, and the direction between those 2 points. So in this case, you can see this is a very simple example. The 3 km and 4 km lines form a right angle. So the displacement is directly from home to school, like so. To determine the value, because this is a right angle triangle, you just need to use Pythagoras theorem, and that's how we get the value of the displacement at 5 kilometers. Now remember that displacement is a vector quantity, so which means that we also need to determine the direction of the displacement. How do we determine the direction? Because we're using a right angle triangle to solve this problem, all we need to do is take the angle between that resultant displacement from one of the lines. In this case, let's take it from the 3 kilometer line. So to determine the angle, we're just going to use trigonometry, which in this case, we can use tangent. So we get tangent of theta equals to 4 over 3, and that's how we get the value of the angle at 53.1 degrees. To calculate the velocity, just like earlier, all you need to do is take the value of the displacement divided by time. So in this example, the time taken is 1 hour, which means that the velocity is just 5 kilometers divided by 1 hour, giving us the average velocity of 5 kilometers per hour. The direction of the velocity is exactly the same as the direction of the displacement. So now that we know what distance, displacement, speed, and velocity are, let's go through the concept of acceleration. Now, the definition of acceleration is the rate of change of velocity. In mathematics and physics, the term rate always means divided by time. It's kind of like how fast something is changing. So in this case, it is the change of velocity over time. The change of velocity here refers to the difference between the final and initial velocity. That's why the formula for acceleration is final velocity minus initial velocity divided by time. So the change of velocity is the final velocity minus initial velocity. This can also be written using symbols of a equals v minus u over t, where u is the initial velocity, which means the starting velocity of the object. V is the final velocity, which is the ending velocity of that particular motion that we're observing. And t is the time taken for this change in velocity. That means the time taken for the object to change the velocity from u to become v. The unit for acceleration is quite simply meters per second squared. Some of you may be wondering, why is it so unusual? Well, it's because this is determined from the formula. As you should know by now, the unit for velocity is meters per second. On the top part of the equation, final velocity minus initial velocity, both are meters per second. The unit for time is second. So based on the equation, meters per second divided by seconds, what you will end up getting is meters per second squared. That's why the unit for acceleration is meters per second squared. Now, some of you might learn acceleration as the change in speed divided by time. This is only true in certain syllabi. For example, if you are taking coordinated sciences or combined sciences. However, if you're taking SPM or IGCSE Physics, you'd have to learn it as a change in velocity over time. Please remember this as a change in velocity because acceleration is a vector. That means it has magnitude and direction. And therefore, to calculate the acceleration correctly, you must use velocity, which is also a vector. Now let's take a look at an example of how to apply this formula. In this example, this car starts from rest, which means the initial velocity of u is 0. It increases its velocity, and after 2 seconds, it reaches the final velocity v of 10 meters per second. So to calculate the acceleration, all you need to do is take these values and substitute them into the equation. So we have a equals 10 minus 0 divided by 2, giving us acceleration of 5 meters per second squared. So because u and v are not the same, they're changing, right? That means there is acceleration. So here we can see that a positive acceleration means an increase in velocity. The value for the acceleration we get is non-zero because u and v are not equal. So what if we get a situation where u and v are equal? Obviously, that would be zero acceleration. So this occurs when the object is moving with constant velocity, where the final velocity and initial velocity are equal. Throughout the entire motion, the object is moving with the same velocity. That's why u and v are also equal. So no matter what the value of the time measured is, you will get zero acceleration. So keep in mind, zero acceleration can mean two things. One, it can mean that the object is stationary. So u is 0, v is 0. They're the same, they're 0, object is not moving. So you get zero acceleration. Or, as you can see from the explanation just now, zero acceleration can also mean that the object is moving with constant velocity. From start to end, regardless of the time, the object is moving with the same value of velocity. Bear in mind, however, that zero acceleration does not necessarily mean that the object is moving slowly. This is a common mistake that a lot of students make. An object can be moving at very high constant velocity at zero acceleration. For example, you can have a rocket moving at 2,500 meters per second. That's incredibly high velocity. But it's moving at zero acceleration if the velocity is constant at 2,500 meters per second from start to end of that particular motion. So remember, zero acceleration does not indicate the slow movement, it just means the velocity is not changing. Now, let's look at negative acceleration. So first of all, the concept of deceleration can be seen from this example. Say an object is moving with an initial velocity of 10 meters per second and it slows down. After 2 seconds, it comes to a stop, where final velocity v is 0. So when you calculate the value of acceleration a, you get 0 minus 10 divided by 2, giving us negative 5 meters per second squared. Because the velocity has decreased, that's how we get a negative value of acceleration. In this situation, because the object is slowing down, this is known as deceleration. However, negative acceleration does not always necessarily mean there is deceleration. So in all the earlier examples, we took the motion to the right as positive. What if the object is moving to the left? So if you remember what you've learned about vectors, if it's moving in the opposite direction, we would indicate that opposite direction with the symbol of negative. So we can have a situation like this where an object is actually gaining speed, but it's moving in the opposite direction. Its initial speed is 0 and its final speed is 10. But in this case, because it's moving to the left, which is the opposite direction, the final velocity is actually negative 10. So when we calculate the acceleration, we would get negative 10 minus 0 divided by 2, giving us a value of negative 5 meters per second squared. The value here is identical to the value of the deceleration in the previous slide. But the motion here is very different. So in this case, the car is actually not decelerating. It's just that it's moving with negative acceleration. In this case, the negative acceleration here means an increase in speed, but in the opposite direction. So sometimes you can get two situations that are vastly different in terms of how we observe the actual motion, but mathematically they appear to be identical. So in case you're wondering, oh my gosh, how am I going to solve questions like this? So when it comes to calculations, don't worry, just substitute the values in and that's the value you're going to be working with. So mathematically, the deceleration and negative acceleration could be the same. It's just that an observation in real life, they're different. So for now, if you're taking SPM and IGCSE Physics, don't worry so much about that. All this complicated understanding of the mathematical numbers and actual motions will only take place at a higher level if you're going to pursue physics. So for now, just to complete this lesson, when it comes to linear motion, sometimes you could be asked to describe the motion. So when describing motion, typically you should have two different words. One would indicate whether the value is changing or non-changing, and also the type of motion. The exception in this case is if the object is stationary, because if it's stationary, it's at rest, it's not moving, there is no need to describe the motion because it's not moving. However, if the motion involves speed, velocity, or acceleration, ideally, these types of motion should be accompanied by the descriptor of constant or uniform, increasing, or decreasing. Let's look at some examples. So as you can see, if the object is not moving, you just need to mention that it's stationary. Next, if the object's speed or velocity is not changing, then you can say constant speed or constant velocity, or you can also say zero acceleration. By the way, the terms constant and uniform mean the same thing. So you can also write uniform speed or uniform velocity. If the speed of velocity is increasing, write that out, increasing speed or increasing velocity. If the velocity is changing at a constant rate, that means it's moving with constant acceleration. And that's another term you can also use. If the speed or velocity is decreasing, you can write decreasing speed or decreasing velocity. If this decrease is at a constant rate, then you can write constant deceleration. And finally, if the speed is increasing in the opposite direction, you can write increasing speed in the opposite direction or constant negative acceleration. So I hope you found this video educational and helpful. Please remember to click like. And if you'd like to have access to more lessons, solutions, and exam strategies, do subscribe. Or check out my website, physicsrocks.com, for the latest updates in the syllabus for SPM and IGCSE Physics, as well as access to the latest video lessons. Happy studying!